From Inform a Tech Target, I'm David Essex, and this is Enterprise Apps Unpacked. Artificial General Intelligence, or AGI, is hugely controversial in the AI and tech industries, and the rest of the world for that matter. It's defined as AI that's so intelligent that it can match the human ability to understand things in the world and apply knowledge to unfamiliar tasks. It's still theoretical, but major companies like Google, Meta, Microsoft, and OpenAI are actively working on it. Obviously, it would be a quantum leap over the quite impressive AI we've had ever since ChatGPT came out 3 years ago and launched what can truly be called, without exaggeration, an AI revolution, a word we tech journalists are taught to avoid. But let's face it, impressive as they are, today's generative and agentic AI are narrow AI and trained on tasks that are simpler to represent and automate in software. They're not general-purpose AI that matches our cognitive abilities. The controversy over AGI comes down to two big issues: whether it's even possible to make computers this smart, and that this isn't just the biggest snow job in the giant glacier of tech industry snow jobs, but also whether we should even want computers that are as smart as us. For centuries, people have imagined what could go wrong with robots and other artificial intelligences. Famously in the Terminator movies, and an earlier classic, 2001: A Space Odyssey, which hit really close to home with its rogue computer, HAL. I'm sure this sounds a little too dystopian, but some of us lean toward the dark side and may be more attuned than others to the downsides of technology. But what if AGI is not only feasible, but actually dependent on humans and could ultimately be the ideal collaborator? Today's guest, Nick Karinos, thinks he has an answer to these AGI problems. AI has been his life's work for 4 decades, and today he's founder and chief AI architect of FoundTech, an applied research lab that develops and licenses foundational technologies, algorithms, and frameworks. FoundTech claims its research demonstrates that true AGI emerges not from replacing human intelligence, but from enhancing it through mathematical rigor and systematic progress. What does mathematical rigor mean in this context? We discussed that in the podcast, why a human-machine symbiosis might be the solution to AGI problems, how that symbiosis would work in practice, and what it might mean for humanity. And probably most relevant to this podcast, we talk about how the changes that this type of AGI could bring to enterprise applications will differ from the changes we're already seeing with generative and agentic AI. Don't forget to rate, review, and subscribe to Enterprise Apps Unpacked for the real story on the software that runs your business. Nick, thanks very much for coming on the podcast today.
Thanks for having me, David. Excited to be here.
You've been deeply involved in computers since you were 11 years old, as I understand it, and I'm wondering if you can share some of your personal stories, such as what drew you to computing in the first place and how your experience evolved to the point where now you're trying to solve one of the biggest problems in computing.
Well, something, whether it be a movie or the other, got me excited about the idea of computers. And I convinced my dad to get me a computer. He got me in 1981, a ZX80, which I think had about a kilobyte of memory, not anything compared to today's computers. But, I didn't play games or anything. I learned to code pretty quickly and just immersed myself further, and then got another computer and found friends that had more powerful computers. I joined computer labs and had access to computers. And, once I had sort of become pretty good at coding and the mathematics involved, I started asking myself the question, what would it take for this thing to start thinking? Because it's not intelligent in any sense. It's doing what I tell it to do. And I then read a book on AI and robotics in 1982, and I just decided that's what I wanted to do for the rest of my life. So I immersed myself into AI, read everything I could, built AI applications. They were pretty basic initially, but I kind of got into it, read everything I could, studied all the mathematics related to it, and just during the winters, I just kept going. I also discovered entrepreneurship. So I very much am a believer in the practical application of the work that I was doing, not just, sitting in a lab and doing theoretical research.
Yep. And we like to get practical here, so we'll get into that, I guess, a little later.
Right.
So artificial general intelligence, or AGI, is controversial in part because it's considered much harder to achieve than the special purpose, often fairly narrowly focused AI that we've been seeing recently in terms of like generative AI and agentic AI. And FoundTech is an applied research lab working on this very problem of AGI. And it makes a general claim, and I hope I have this correct, that the solution is through a human-machine symbiosis, not by trying to build AGI that can replace human intelligence. So I'm wondering, why do you think this symbiosis is the best approach?
Okay, so first of all, let's just define the term AGI from our perspective, because it ties into the answer to the question. So when I started out, AI was what we now think of as AGI. Now you'll hear two terms thrown around and sort of used interchangeably, and one is artificial superintelligence (ASI) and artificial general intelligence. And in our sort of world, the term AGI means something a little different to what others use it in their definitions. So general intelligence for us has to do with breadth, right? So in other words, the ability to be good at multiple subjects, not just chess or some Atari game, for example. So if a model's able to do multiple things, it becomes general. And then super intelligence is depth. So that the more intelligent it becomes at each of these domains, the more super intelligent it is. And so for us, the objective is to achieve both AGI and ASI because we want the breadth and the depth. And the second thing I'll say is that I don't believe it's a sort of 0-1. It's not a digital outcome. We all of a sudden have achieved it. It's a continuum because think of the breadth, right? As you sort of become really, really good and you have super intelligence at a really big list of general subjects, well, the world doesn't stop, right? New subjects are being added. Therefore, the generality of it has to continue expanding. And as we get better at each of these subjects, you have to keep going deeper. So for us, it's a never-ending journey, right? So there isn't a point at which you've achieved AGI and ASI. So I'll say that. To your question of the symbiosis between humans and machines, it has to do with the fact that, first of all, we are trying to emulate or simulate human intelligence. I mean, that's exactly what AI has been about from day one. It's trying to create the intelligence level of humans and hopefully beyond. Now, they are looking at the field largely looks at one dimension of intelligence, and that's what we call computational intelligence, right? So it has excellent recall. It's able to identify with phenomenal accuracy patterns in seeming abstraction. And that is one dimension of intelligence. Human beings have embodied intelligence, right? So we've got creativity, instinct, values, et cetera, et cetera. But these are not generally considered aspects of intelligence, right? So we're building a very unidimensional model. So for us to truly build a machine that is as intelligent or more so than humans, you have to account for and train for all these other dimensions of intelligence, not just computational intelligence. So without humans in the loop, actively in the loop, and I'm not just saying approve or, thumbs up or thumbs down to whatever output it creates. I'm talking about actively being involved in creating the data sets, in the usage of these machines, to the point where ultimately they're able to understand us and emulate us to a certain extent. But it's, we've got millions of years of evolution sort of bred into us, and that's not something you can easily impart in these machines. So I don't think that AI will ever be able to completely leave humans out of the equation. It'll just end up being something that's not necessarily super and generally intelligent.
Mhm. In your LinkedIn profile, you say that FoundTech's research demonstrates that true AGI emerges not from replacing human intelligence, which you've just alluded to, but from enhancing it through mathematical rigor and systematic progress. Can you elaborate on this? How do the mathematical rigor and systematic process manifest themselves in this scenario?
Right. So the mathematical rigor partly is in the models, but it's largely in the process. So we do not release or deploy anything unless we can prove mathematically that it works and we can explain mathematically why it works. So, we don't just build fast and break things as the industry tends to do. The mathematical rigor comes in those proofs and that process of proving that what you're building works and you're able to explain why it works. And this ties into numerous fields of AI like mechanistic interpretability, which is trying to get AI for us to understand what's inside these black boxes. We're saying you need to do it in advance. So, we use a lot of the techniques that are being used by everybody else, but we do so with a lot more mathematical rigor.
Mhm. I assume it's the AI that provides most of the rigor and the systematization, but how do the two, the human and the AI, interact? In other words, what goes on in the interface between the human and the
Yeah.
machine in this symbiosis?
That's a great question. So it really depends on the context. So I'll give you an example of one of our products that we're building, or one of the models we're building, called Humanics. And the way that works is what we're trying to do is, because data is everything in AI, we are trying to create a data set. We are creating a data set that has the human traits and the human elements baked into it. So how this works is, imagine you could be anything. You could be somebody who restores vehicles. You could be a really excellent plumber. But let's just, for argument's sake, say you are a professor of mathematics and a researcher in mathematics. And you would basically interact with Humanics, where instead of you prompting the model, like, you would sit in front of ChatGPT, for example, and ask it questions or give it tasks, and it would perform them. It works the other way around. So at the core of Humanics, we have what's called an engine, essentially. I won't get into technical details, but it's a curiosity engine, if you will, that creates a list of known and unknown questions. What does humanity not know? What does AI not yet know? And we've curated and built this list, and we continue to do so. And so if you were this professor or the plumber or whomever, you'd sit in front of Humanics and it would ask you questions. But so you would give the answer so that using your computational intelligence, but then it would create derivative questions that align with the human traits. And we've identified hundreds of them, right? Everything from instinct, intuition, creativity, etc. So the AI would reframe the questions in a way that doesn't require your computational intelligence, but would say, right, instinctively, if you were to try a completely different approach, regardless of whether it works, no one's judging you here, what does your instinct tell you might be useful here? Using your transfer learning ability and your embodied intelligence, what else might you try? How else could you do this? And if it's relevant, how does that make you feel? Does it align with your values, et cetera, et cetera? So assuming those questions are relevant. So the AI is constantly extracting from the human a multi-dimensional data set that is then used to train AI. And obviously what results in AI that is a lot more human and understands humans a lot better. And then when other humans interact with the AI that's created, you see that instantly. It's a completely different experience.
Mhm. At FoundTech, where you are the chief AI architect and research director, your focus is on the theoretical foundations, but you're also a co-founder of two startups, and maybe more actually, that turn the foundational work into applications for business. Can you describe for our listeners what the two startups do? And maybe I think you might have just described one of them, and how your work at FoundTech translated into those products.
Yeah. So FoundTech is both, as you said, a research lab, but we're also a venture studio. So when the research is ripe for commercialization, we'll then either license that to others or build a business out of it, right? And at any one point, I'm involved in one or two businesses actively in an executive role. So the first business is Sprite, Spryt. And with my co-founders, I'm not the CEO of the business, I'm the chief AI officer. We set out to solve the problem of non-attendance of medical appointments. So missed appointments, right? So not just sending reminders, but really diving deeper into determining when a patient is likely to miss an appointment. And then another model will then interact with that model and do what it can to reduce the probability of them not attending the appointment. And there's a learning cycle. So it gets better and better at understanding people and doing what it takes to get them to the appointments, because missed appointments, cost the NHS and other health systems billions of dollars. But more importantly, missed appointments can cost lives and have health risks, right? If you're missing a cancer screening test, that could have substantial consequences. So this is it's an important problem. And the reason I became involved as an executive and co-founder and actively involved in building the business, and it's doing really well, is because I believe this is an important problem to solve. And as you could see, it has to do with that human machine symbiosis. It's using AI to understand people and then do what's best for them, essentially.
Mhm.
So that's the one business. The second business is called RAIDS, which stands for Rogue AI Detection System. And it's exactly that. It's a system that uses numerous technologies, including autoencoders, which are types of machine learning algorithms and models that are able to mimic what's going on in another model. And what RAIDS does, again, without getting too technical, is it determines how a model should be behaving, or an AI system or an AI product. And then it'll flag the user, the company, the developer, whoever's using it, when that model is starting to deviate from its intended function, right? So in other words, it's deviating from baseline, or it's creating anomalous outputs. And essentially it's a smoke detector, right? It'll alert people to say, listen, this model is becoming very risky. For these reasons, here's the explainability, here's the explanation, here is the data that verifies this. You need to go and look at fixing this issue. And that's another business that's doing very well. And the reason I became executive in that is, again, I feel that, AI safety is not being taken seriously enough, because there's just this massive euphoria just to build AI, but not enough has been done to create safety. And having human defined guardrails is not enough, because the things that can go wrong will be at the edges. They'll be, unpredictable, right? So you need something a lot more pervasive that's going to be able to detect deviations and drifts and so on at a very granular level and then help stop them.
Mhm. So if you could extrapolate this approach that you're taking in your company and with the startups, if you could extrapolate to the broader enterprise application market, how do you think business applications might change, especially compared to what we're seeing last few years with the generative and agentic AI that has been kind of infused and embedded into applications?
Well, yeah, I'm glad you said agentic AI, because that is, we haven't really seen true agentic AI. What you're going to see this year and next year and the following year is going to completely change the way we view AI. I mean, right now, the paradigm is you ask it to do something, it does it, you integrate it into your work, and off you go. Um, and I don't know if you've ever sat down in front of, ChatGPT or Claude, and it asked you something or it suggested something to you, right? It's very reactive.
Yeah.
What we're going to see is these things are going to get connected to absolutely everything: your email, your health records, your financial, your bank account, your stock portfolio, literally everything. And it'll have full panoptic context and will be able to do things for you. So the notion of an interface is going to go away. It's going to be very much involved in every aspect. It's going to use all your software for you. And in fact, even the notion of applications and software may disappear. As long as you're getting the result and the data from it, then that's all you really care about. So that's going to be the big thing. This is the year the beginning of, I'd say, half a decade of the agentic era of AI. We're going to see it really improve exponentially, be used exponentially. And then, of course, there are some risks and downsides in terms of job displacement and so on and so forth. But I think, we'll figure out solutions to those. And we obviously have a few of our own ideas around that.
Mhm. So, just so I understand, the AGI approach that you're taking, is that going to be like a better type of AI that will then go into the agents and improve agentic AI over the next decade?
Absolutely, yeah. So the underlying component of all of this is intelligence, right? So as intelligence improves, the agents will improve. The agent part of it essentially refers to the fact that these models or systems have agency. They're able to take action, be proactive, et cetera, et cetera. But the underlying intelligence is going to be something that's going to keep improving with some of our work and then some of the great work that the other labs are doing. And the agents will become better, right? Because think of an agent as an employee. The smarter and more experienced that employee becomes, the more effective they're going to become.
Mm-hmm. There's been a lot of concerns, speaking of employees, in the past year or two from workers who are worried about their jobs being handed over to AI. And there is evidence from some big companies lately that is starting to happen. Would you say that focusing on this human AI symbiosis is the best way to avoid that kind of danger of AI, such as job loss, but also other known problems of AI, such as bias and hallucinations?
Absolutely. Yeah. So to an extent, yes, on the first point, definitely on the second point. Um, the solutions to the problem are numerous. So number one, we keep hearing about Jevons paradox and how when something becomes more efficient and the cost reduces, the demand for it increases, right? So as the cost of computation comes down, the demand for the result of computation increases. This is going to happen to an extent within companies, right? Because with the cost of the output, the work output reducing, that'll pass on to consumers, customers, and the demand will increase. So companies are going to grow as a result of employees becoming a lot more efficient because the output's going to increase. So to an extent, that's going to slow it down. It's going to be a good buffer. It's going to give us a bit of time, but we're already seeing the displacement. The World Economic Forum predicts, I think, 92 million job losses by 2030. Another statistic I read said in the US, approximately 500 jobs a day are being lost. It's a big number directly related to AI. So your question around the symbiosis. So the main reason we're building Humanics is to give. So as we spoke earlier about the mathematician and the guy who restores cars and the plumber, all of these people teaching AI, you actually get paid for doing that. And you get paid a meaningful amount, right? Why? Because there is a substantial demand for this data. And because this data is very deliberate and very high quality, given the process that we go through, and it's got the human traits built into it and profile data built into it, it's very valuable data. Therefore, we can fetch a lot for it, 90% of which is then passed on to the people who are actually teaching the AI. So that's one way, right? You get displaced. You're an expert at one particular thing. The AI needs to keep getting better at that. So you can work with systems like Humanics to make a meaningful income from any computer, right? So that's one way to do it. The second thing I spoke about is the Jevons paradox issue, where companies will keep growing and hiring more people that become more and more efficient because the demand is growing. But a term I think I coined, I didn't hear anybody using it in this context, just before COVID, is micro entrepreneurship. A lot of people that get displaced are that have never been entrepreneurs before are going to have a set of tools because of these agents and this powerful AI that will enable them to build a business. Now, it might be a one-man business, and it might be a business that makes just enough for them to live a comfortable life. But you're going to see a lot of people, so that the shape of work is going to change substantially. So instead of me working for you and you paying me a salary, you're going to see a lot of those people move out, and you're going to see thousands upon thousands or millions of businesses spun up that have one or two people that are run by a little family that are able to make money because the tool set that you need to build a business are there. The agents are like employees. They're going to be extremely cheap, able to help you build these businesses. So those are three things that I believe are going to make a big difference to solving this problem. And humans are ingenious. We always figure out solutions to problems. There is going to be displacement. I just worry about the lag between the displacement and these solutions kicking in.
Hmm.
But we're doing our small part to try and deal with it. But it's going to come in a big way.
If this human AI symbiosis happens or begins to happen, do you think it could change humans in some way? I mean, at the level of their intelligence and their sort of their consciousness and their psychology?
It's going to change the shape of our intelligence, right? So every technology has changed us. I mean, the pen changed us, being able to write changed us, computers changed us already. What I think is going to happen is that, earlier I spoke about embodied intelligence, which is what we have, and AI has computational intelligence, and it'll gradually learn some embodied intelligence. But what's going to happen is you're gonna see a divide, a shift, where humans are going to be doing less computational activity and more of what they are uniquely capable of. Machines will be shifting and becoming even and doing more and more computational activity at a higher scale, higher level. And because we're going to move sort of, you're going to see that polarization, the need to then work together is going to increase dramatically. Because when the AI is interacting with humans, it needs to truly understand the emotions and social norms and cultural norms and the belief systems of certain people and so on. And you can't just give it that data and assume it knows it because each situation is unique. So you're going to need humans in the loop to help through that process. So the need for us to work together is going to increase dramatically because of this polarization.
Mhm. Isn't there also a danger, though, of making people think and act more like machines? And I'm assuming for the moment that that would be a bad thing. Although, as I'm thinking it through, I'm not so sure. But is that kind of a risk here of, people acting more like the computers?
It's happening, but what I fear even more is people are into thinking less. I mean, without naming names, I mean, I interact with a lot of different contractors and vendors and so on, and they'll produce something amazing, and you read it and think, wow, this is really great. You get on a call and you ask a few questions, and it's very clear to me that they simply had an AI produce this and don't even fully understand it themselves or have vetted it. So we're not going to think more like computers. We're going to slow down our thinking, which is bad. But this polarization, right? Let's focus on what we're good at. Let's focus on the creative endeavors and the things that need our intuition and this, millions of years of embodied intelligence we've accumulated, and see how we can have that be our reason to exist and for us to sort of flourish and succeed in that area. So I'm not too concerned about that risk.
Mhm. What kind of progress do you think is likely in the next 5 to 10 years from found tech and in the broader AI industry toward AGI in general, especially in how it could affect business use of AI?
Well, as you know, in business, I mean, I think 90 something percent of pilots never materialize or never convert into actual implementation. Um, the next 5 years are going to, the amount of progress we're going to see will be probably about as much as we've seen in the last 100 years. It's going to be dramatic and major. For anyone to say they know exactly what's going to happen, they're lying to themselves, they're lying to us. It's going to be too difficult to predict, but I can tell you that the shape of companies are going to change. As I mentioned, the nature of employment is going to change dramatically. AI will be used a lot more to produce the outcomes that we are currently producing and more. But whether that sits with micro entrepreneurs, because businesses will look different, but looking at enterprise, absolutely. Without having agents as employees, you'll be outcompeted and you'll be left behind. because I think there was a CEO being interviewed. I watched the interview briefly the other day, and I think it was McKinsey where he was asked how many employees he had. The CEO was asked how many employees he had, and he gave a number and then specified to say, well, of those, X% are agents. So he actually considers them employees, because for computational intelligence, David, we're going to be left in the dust. There's no question. And if you don't put these computationally intelligent agents to work within your organization, you're going to be left in the dust. So it's going to become an imperative. So the adoption rate is going to increase dramatically. But what that AI looks like, what shape it takes, how it interacts with employees, how it impacts on employees, those are still unknowns we need to be thinking about and talking about and trying to figure out solutions to.
So it's better to get ahead of it and go with the flow rather than trying to fight it, per se. Yeah. Well, Nick, I appreciate the fascinating discussion and that you came on the podcast today. Thanks again.
You're welcome. Thank you for having me, David.
Thank you for listening to Enterprise Apps Unpacked, where we give the real story on the software that runs your business. To learn more about business applications, explore our content on searcherp.com. Find us on YouTube at our channel, Eye on Tech. Subscribe to our podcast to receive the latest episodes as they drop. And if you liked what you heard today, give us a rating and review on Apple, Spotify, or wherever you're listening. Until next time.
Podcast programming and promotion by Kelsey Waddell. Music supplied by DP via Getty Images. This is an Informa Tech Target production.